Hi guys, so in this video we're going to carry on looking at some indices rules. Make sure you have a look at Mr. McKelwey's video that he did first, because that's got some rules that we're going to build on this particular video. So the first one we're going to have a look at is this rule here, where if you have, in this case, say x to the power of a, and if that's in brackets and we have that to the power of b, all that means is that we multiply those two powers. If we have a look why, if I have this example here, k to the power of 8, and all of that is squared, well remember, squared just means times it by itself, so that is exactly the same as saying k to the power of 8 times k to the power of 8. And just like in that first video that Sir did, when you've got k to the power of 8 times k to the power of 8, these are the same. All we do is we just add the powers, so that'd be k to the power of 16, which as you can see is just the same as saying 8 times 2. So quick version then is this one here, so c to the power of 4, that's cubed, so obviously it's c to the power of 4 times c to the power of 4 times c to the power of 4, or we can just use this rule and just do 4 times 3, which is 12, so c to the power of 12. Okay. Gets a little bit more interesting here, and this is where mistakes start to happen, is people just seem to ignore this 2. You can't do that, and I'll show you why. Again, it's cubed, so that'd be 2xy to the power of 5 times 2xy to the power of 5 times 2xy to the power of 5. In case it's cubed, so I'm timesing it by itself 3 times. Well, look what happens. 2 times 2 times 2, you have to do that. You can't just leave it. So 2 times 2 is 4, times 2 is 8. So I'll probably write the answer down here is 8. X times x times x is x cubed. And then x to the power of 5 times x to the power of 5 times x to the power of 5. So not x, I'm going to talk about y to the power of 5, y to the power of 5, y to the power of 5 would be y to the power of 15. And if we look at this rule here, I'm doing 2 cubed to get me the 8. X cubed is always just x cubed, and then x to the power of 5 cubed, we times the powers to get y to the power of 15. I keep calling y x, I'm just, again, in the mood for x apparently. So yeah, y to the power of 5, if that's cubed, we times those powers. So again, I'm not going to write this one out, I'm just going to go straight using this rule. 4 squared is my 16, x squared is just x squared. Now y, there we go, got it this time, y to the power of 4, if that's squared, I times the powers, so I get y to the power of 8. Okay, so the key thing there, people are usually happy with this rule, but then when it gets to a coefficient in front of the x or something like this, people then forget to actually still cube it in this case, or square it in this case, so make sure you don't do that. The next rule to have a look at is this one here. Anything to the power of 0 always equals 1, except if it is 0. So if it's 0 to the power of 0, then it doesn't quite work. But anything else to the power of 0 equals 1. So very quickly, 5 to the power of 0, yep, you guessed it, is 1. Y to the power of 0, yep, you guessed it again, it's 1. Okay, so they're the 2 extra rules that I want to introduce into this video. Now, this next one is a very, very, very tricky question, and it links into simultaneous equations. You can trial and error it, of course you can, you might get the right answer, but I'm going to show you how you use simultaneous equations. So it's one of these top-level questions that you might see that links in with some of these indices questions. So let's give it a go. The first thing to do is, remember that video that Sir did before this one, which you should have hopefully seen first. 5 to the power of x times 5 to the power of y equals 5 to the power of 12. Well, if we just concentrate on the powers, I can write an equation. When you're timesing like this, we can add the powers to get that power there. So I've got x plus y, and that must equal 12. That's what that first one says. If I add those two powers, I'm going to get that one there, which is 12. Now in this case, I've got 5 to the power of x divided by 5 to the power of y, I get 5 to the power of 6. So if you remember the rule that Sir talked about before, when you're dividing, you're actually taking the powers away. So that'd be x minus y, and then that's going to equal 6. Okay, so I've formed a simultaneous equation, which I'm now going to solve. I'm going to use the elimination method. So I'm going to get rid of these y's, because I've got one y on each one of them. I could get rid of the x's if I wanted to, but I'm going to stick with the y's. So what do I have to do to these two equations? Well, I have plus y and minus y, so I'm going to want to add these two together, because then when I do y plus minus y, they're going to eliminate, hence why it's called the elimination method. But don't forget to add everything else. So x plus x gives me 2x. Like I just said, y plus minus y is nothing, that's why we do it. And 12 plus 6 is 18. A little bit of rearranging. If you want to, divide both sides by 2, or hopefully you can just spot it. The x must be 9. Okay, so you can divide by 2 both sides if you want to, but 2 times what gets you 18? Well, x must be 9. As soon as you know x is 9, you can put it into one of these two equations. I'm going to put it into the top one because it's nice and easy. So if x is 9, I'm going to have 9 plus y equals 12. And again, you can rearrange it if you want to, but hopefully 9 plus something is 12. You should notice that y is 3. Okay. Whenever you get an answer, please check it. Let's have a look. Does it work? If I think x is 9 and y is 3, 9 plus 3 is 12. Yep, that works. And then 9, take away 3. Yep, that gets me 6. So there we go. I've worked out my values for x and y. Again, some tricky questions that you could be asked is something like this, where we're told in the question that a equals 2x and b equals 2y, and we've got to express these in terms of a and b. So this is very, very tricky, and initially people look at this and go, oh, I can't do it. Back yourself, guys. Remember the rules. Take it step by step, see what we can do. If I've got 2 to the power of x plus y, we can use the first rule. So that's just 2 to the power of x times 2 to the power of y. Okay? Those two are exactly the same thing. 2 to the power of x times 2 to the power of y. Remember, I add the powers, so I would have that 2 to the power of x plus y. So I've just rewritten it to be like that. And then it's really easy. Well, what is 2 to the power of x? Well, we're told up here it's a, so that's just going to be an a. I'm going to times that by 2 to the power of y, which I'm told up here is just b. So I'm just doing a times b, so simplify that to be ab, which is obviously your answer. This one here, 2 to the power of 2x. Well, remember, 2x just means 2 times x, so which rule are we dealing with there? Well, it's the very first one I did on this video, so that's just the same as saying 2x, and then in brackets, squaring it, because remember, when we had something like this, we times the powers, so 2 times x would give me the 2x. So I'm just rewriting that to be in the format of the first rule I did in this video, in which case, again, 2 to the power of x is just a, so I'm going to substitute that in, so I'm going to have a squared. Nice and easy. Exactly the same one for this one as well. I'm going to use that 3 times y, so again I'm going to use that rule that I did on the first rule I did in this video. So I'm going to have 2 to the power of y in brackets, and I'm going to cube all of that. So if I was to do 3 times y, I'd have my 3y. What does 2 to the power of y mean? Well, it's b. And then obviously then I've still got a cube, so it's b cubed. And last but not least, which is the very juicy question here, and we've got 2 to the power of x plus 2 to the power of y. Remember, when we plus the powers, it means that we're timesing. So I would have had 2 to the power of x times 2 to the power of 2y, because then I would add those powers. Still not quite finished though, because I've got 2 to the power of 2y, so I'm going to include this rule here. So that's going to be 2 to the power of x, that's going to be the same, that's not a problem. And then 2 to the power of y, and again in brackets, because I'm going to square the lot of it. So 2 times y gets me my 2y. Substitute in our a's and b's. Well, 2 to the power of x is a, 2 to the power of y is b, and obviously I've still got to square it. So a times b squared is ab squared. Okay, so it's just some different ways they can question you on indices, and hopefully that helps. Cheers, guys.